Once the house is sited into position, trenches are dug in preparation for the foundation, and straw bales are delivered to the construction site. The production of cement generates approximately 7% of all greenhouse gases on the planet, a fact not known to most people. Therefore, how and where this material is used in the building of this house will receive careful consideration. In some cases, it will not be used at all, but instead be replaced by a more sustainable alternative. In cases where concrete is appropriate, it will be used judiciously, serving whenever possible multiple purposes of structural component, aesthetic element, and thermal mass. Foundations use a substantial amount of concrete, particularly when the foundation is 18 inches wide, the width of a straw bale wall. A rubble trench foundation reduced the amount of concrete used here by more than 50%.
One way of making a foundation for a straw bale house is to dig a trench that is about 18 inches wide, the width of a straw bale, and as deep as the frost line. Let's say it's 20 inches in your area. Code requires that the foundation be insulated, so we placed 2 inches of foam on the outside edge of the foundation. This slows down the heat loss through the foundation. This entire area is then filled with concrete. You end up with a huge block of concrete that is just total overkill for this type of wall. We are going to use a rubble trench foundation. It is also extremely strong and reduced the amount of concrete by over 50%. The 2 inches of foam insulation is still installed on the outside, and a French drain is then placed at the bottom of the trench. This is a 4-inch diameter perforated pipe that is required by code. Now comes the good part. Most of the trench is filled with 1.5 to 2 inch broken stone. This is why it's called a rubble trench. The rubble is what replaces the concrete. Only the top 8 to 10 inches of the foundation will be a grade beam of concrete. There are 2 pieces of rebar that are also required by code. Now compare the 2 foundations. This solid block of concrete has been reduced by over half in the rubble trench foundation, without any reduction in structural integrity.
Now that our trenches are dug, we can start laying the perimeter drain, which runs around the entire perimeter of the foundation. And what it's made out of is basically just a 4-inch perforated pipe. And this will allow any water to drain out if it were to get into the foundation system sometime in the future. What happens is it goes through the perforations here, and then we have it a slight slope draining out to the lower side of the property.
This is the 2-inch thick foam that is on the outside of the foundation. It has an insulation value of around R10. In this foundation, it will serve 2 functions. Number 1, it will act as insulation for the foundation itself, and number 2, it will also serve as the outside form for the concrete pour.
As you can see here, we've laid the foam about 2 inches higher than our string here that indicates the top of where we want our concrete pour to be. When we have the foam in place, we'll then go back and cut the foam off at the string level, and then this will act as the retainer for concrete on this side of the perimeter beam and also act as our screed so we can smooth off the top of the concrete after we pour it.
String that is attached to the batter boards is used to precisely position the foundation, including the finish height. It is much easier to trim the height of the foam later on, instead of trying to position multiple pieces of foam to the perfect height from the very beginning.
To keep the foam aligned to our string markers, we're using 1x2s with a couple of nails in the end. And those are used to warp the foam into position and hold it there. The line that Al is drawing will indicate the top of our crushed rock, and concrete will be poured above that line.
As gravel is placed on the inside face of the foam, dirt is placed on the outside at the same rate. This ensures that the foam does not bow in or out, and it keeps it running in a straight line with our string guide. If the trenches had been dug to the perfect width, the foam could have been affixed smack up against the dirt wall of the trench, and this would have eliminated the need for some of this backfilling with dirt. It's very important to tamp down the gravel and the dirt to ensure that it is thoroughly compacted to prevent settling in the future. Now that we're completing our foundation system, we got to start thinking about plumbing. This is called the drain, waste, and vent piping for the house, which will ultimately end up being underneath the slab. We've dug down up to 30 inches for the toilet piping here, and this pipe here, which runs parallel to it, is for the gray water. This will take care of the shower, sinks, and washing machine. Once the line is outside the perimeter of the house, the gray water pipe passes through a diverter valve that will permit this water to be channeled off to a future gray water recycling system. At the time of construction, gray water systems were not permitted in New Mexico. I assumed that the law would someday change, and they did. Now gray water systems are permitted in the state, and hooking up the system will be quite simple since all of the valves are already in place. By having an accessible diverter valve, the gray water can be made to flow back to the septic system when desired. Once past the diverter valves, both the black water and gray water lines merge into one and then proceed to the septic system.
We're at a point now where we have to install all the underground utilities before we can pour the foundation and slab. And that'll include conduit for both the power, the telephone, and cable TV. So what we're doing here is we've made a maze of trenches around our building project here, routing everything to its proper location. As you can see, the conduit runs underneath our foundation, including the perimeter foam, and into a trench.
We used a machine called a ditch witch for digging most of the trenches for the conduit and plumbing. It makes a trench about 5 to 6 inches wide, which is just wide enough to drop in the pipe very conveniently. We used copper pipe for all of our freshwater plumbing. This trench contains 2 freshwater lines using copper pipe, in addition to a plastic line that will carry water from the cistern for non-potable uses within the home.
These are the forms for the foundation for the adobe walls that would be the interior walls of the structure. They're constructed out of 1x8, which I acquired from a friend's renovation project. So we're using recycled wood for the forms, since when they're poured with concrete, they get pretty much thrashed and useless for much else. This string here is indicating the top floor level of the foundation, and the top of the interior wall foundation is at the exact same level as our floor. We'll lay the adobe bricks directly on top of this.
The next step is to install the rebar in the concrete portion of the foundation. And steel support chairs are used to raise the level of the rebar a couple of inches off the ground. And this ensures that the rebar will be suspended within the concrete and not laying just directly on the ground. And note that the rebar overlaps at the joints and crosses from the inside to the outside at the corners. And this is done for additional strength. The foam will now be marked to the height of the finished pour of the concrete, and this is done by using a very simple device called a water level.
It's a pretty handy little device.
Basic business.
It's nothing more than a long tube filled with water. Due to gravity, water at one end of the tube will always be at the exact height as it is on the other end. From our survey stakes, we pick a point that indicates the proper finish height, and this becomes our master reference point. The other end of the level is then taken around the foundation, and this same height is marked there as well, since the water is always level. It's a real low-tech system that's very simple and accurate. While moving the level, each end is capped to prevent the water from spilling out the other end when one end is higher than the other.
Okay, capping.
Capping. Cap on.
Next, Tom and Al will snap a chalk line to connect the elevation marks on the foam. Some 2x4s can be clamped to the foam to act as a guide while cutting the foam with a handsaw. As you can see here, we're using straw bales for the inside form of the concrete. Once again, this saved on wood since we had the straw bales on hand. Either metal stakes or adobe bricks were used to keep the bales in place. It's then just a matter of nudging the bales to the 18th inch width of the foundation.
Good.
Tar paper is then attached to the bales so the concrete will not bond to the straw, and nails were used to pin the paper to the bales. The final step was to hammer number 4 rebar into the stone rubble. This vertical rebar will extend high enough to go through 1.5 bales of straw for the finished wall. There are 2 rebars in each bale, and the aluminum cans you see here are strictly for safety so that no one gets cut by the rebar during construction. So that's it. We order the concrete and we're ready for the pour. We had to use a wheelbarrow in a few places when the chute from the cement mixer would not reach.
And now what we've done after doing an initial screeding to the right depth, we're coming in with a trowel and smoothing it out, and we're going to drop in the anchor bolts for the post supports. The foam is at the proper height. The straw bales are a little too high, so we're just using a 2x4, resting it on the foam and screeding across. We can rest a level on here and make sure we've got it approximately straight all the way across. And we just kind of rub it back and forth. Then once we do that, we'll take the anchor bolt and we're going to rotate it once it's in to face this way. That allows the aggregate to pile up on top of here so this can't pull out. So we're going to dig it in, and then I'm rotating my hand as I'm doing that to get the anchor bolt facing inwards, the bottom of the L. And again, we'll keep that at about 1 inch height. We'll come back with a string laid along to make sure this anchor bolt is in line with all the other anchor bolts. Okay, let's line it up again. You note the step down here where this is where a door goes, and it's 2 inches lower than the rest of the foundation. The rest of the foundation is 2 inches higher because the straw bales are going on it, and code requires that it be raised up a couple of inches. So it dips down where the door is, so our door pad right here is at the same level as the rest of the house floor. One thing that we did that was a good idea was to leave this one foundation fill for last in case we ran out of concrete at the end. And we did come up a little bit short, so this was perfect because if we have any left over, we can manually fill this in. Otherwise, it was left empty to fill in at a later date. And since it was its own little self-standing unit, that wouldn't have been very hard to do. we will let the concrete set with the plastic for at least 5 days. The slower the concrete cures, the stronger it becomes, so there's no rush here in drying it out.
Several days later, the forms are stripped away, revealing the finished foundation. Now we can start to prepare to pour the floor.
The floor for the entire house will be exposed concrete that has been stained to a stone-like patina. This will eliminate the need for carpet and will also make for good solar energy collection. Not only is this floor easy to maintain, it is so durable it will never wear out. In addition, the concrete will make a good conductor of heat for the backup hydronic radiant floor heater.
What we're starting to do today is to lay down a vapor barrier beneath the floor area. That's going to be followed by an inch of foam that will act as an insulation barrier for the radiant floor heat. Up on top of that, we are going to put down a couple of inches of sand. And the sand is just to keep the foam from blowing around. It's been windy for the past couple of days, so that has really helped. The remesh is rolled out on top of the sand, and the radiant floor tubing will then be attached to the remesh. The water for the radiant floor system is heated with natural gas and is used as a backup to the passive solar heat. The entire floor area would then be filled with 4 inches of concrete, and this surface will act as the finished floor.
I think it's worth cutting, we'll just keep it this.
This is the coil of the radiant floor tubing, and it comes in one continuous loop that's about 660 feet long. The radiant tubing just loops up on top of the remesh, and at every couple of feet or so, we've attached it with a couple of twists of rebar ties, which is just a piece of wire here. This radiant floor tubing is made out of PEX, and it's been used in Europe for quite a long time. And the nice thing about radiant floor tubing is that it puts the heat where you want it, at your feet, and it heats up the lower portion of your living area the fastest. If you use forced air heat, the heat tends to come out of the forced air vents and immediately go up to the ceiling. This is more like heat from rock and sunlight. It gets warm and it slowly radiates up. There's no dust blowing around, no movement of air. Radiant floor tubing is probably the most expensive heating system to install initially, but it's one of the most inexpensive to run once it's installed, since it's so efficient. And one advantage of using the radiant system in this area is that the local supplier of radiant tubing figured out all the heat loads for us, told us how many loops to put in and how many zones to divide the structure into, which saved us a lot of work. Basically, I took the floor plans to them and they figured out everything, gave us the supplies, and here we are today laying it out. Now that all the radiant floor tubing is in place, it's time to hook it up to the header. And the header is a piece of copper pipe that on this end connects the plastic tubing to a copper pipe, which then goes to our boiler, or in this case, a hot water heater. This upper header here with the orange tube coming out is the hot water in. This is the pipe that will connect actually to the hot water heater. The water will flow in this direction, go through the whole rear portion of the structure, and this is the cold return. The water comes up here, it's lost a lot of its heat while giving it up inside the floor. This copper pipe then takes it back to the hot water heater, it's reheated, and it returns through this pipe.
We're now pouring the concrete floors, and we're going to do it a bit differently than is usually done. The fast and efficient route would be to bring in a cement mixer truck and pour one continuous slab. However, the artist side of me wants to get in there and have additional time to manipulate the concrete into more organic patterns. Therefore, we're going to pour the floor in small sections so that we have time to make artistic decisions before the concrete sets.
Now, another reason for going with this kind of different freeform pattern is because a straw bale house inherently doesn't really have any straight lines. Straw bales are soft. It'd be very hard to get a perfectly smooth surface on it. We're using adobe. Everything kind of has a little bit of a handmade feel. We'll be using mud plastering later on. So to tie the floor in, if we had used a very rigid, very slick surface with square stress mark lines in them, it might not quite have flowed in as well as doing something that's much more freeform like this. So we have curves. Everything in this is kind of curving. Even the floor is not perfectly straight. You've got to kind of subtly pick up a feeling of just, again, the handmade feel of the whole structure.
We mixed the concrete for the entire floor in a rented cement mixer. I had to have an idea of my floor pattern so that we could pour it in irregular sections. This was really a labor-intensive project, and that we were always racing the clock to finish a section before the concrete set up. We screed the concrete, followed up by working it with a wooden trowel, and then finishing up with a pool trowel.
One technique I used for kind of sketching out these lines in the floor was to take a bamboo stick and just by standing up here, just looking down and sketching in. And from being a few feet away from it because of the length of the pole, it was really easy to see what my patterns were doing. And now I'm just going in and finding those light lines I scratched in with a stick and just etching them in even further. And what I'm using is an edging tool here. And I'm basically just going in and pressing it right into the wet concrete. And you kind of have to dig it in to cut through the aggregate. Like that. And like I said, we're leaving this kind of rough. So I'm then just going over it with a pool trowel and letting it crack and kind of do what it wants. And it's going to be a little uneven, but that's going to be part of the look on this particular floor. Come in with a triangular trowel. So you just keep on going back and forth on this till the cracks kind of look the way you want. You've got the pattern the way you want it. And as it sets up, you can just slowly keep on going back and working into the seams. That's about it. Notice here that I'm using a panel, a plywood panel, so I can get into the wet concrete without my knees sinking in. So I just am leaning on this, and this is distributing my weight over the wet concrete. And it will leave a little bit of a dent when you're through. And that can be cleaned up with the trowel.
Pouring this floor has made for an exhausting few days. However, our hard work has paid off. We've ended up with a floor that's a little bit unusual from the standard concrete floor. And this will look really nice when we finish it up with acid staining and grout a little further down in the project. Finally, from this day forward, the house will start to grow in a vertical direction.